Since the frequency response of HAJ omega squared is monotonically decreasing, the maximum error in the passband and stopband occurs at the band edges, passband omega and stopband omega respectively. Therefore, the following specifications are required, which is HAJ omega squared is equal to 1 divided by 1 plus J omega P divided by J omega C with the power of 2n equal and lesser than 1 minus delta P squared. After we rearrange this equation, we have the ratio of passband omega with cutoff omega with the power of 2n must be equal and larger than 1 minus delta P, the passband ripple deviation with the power of negative 2 minus 1. This is the first equation. The next one, the frequency response of HAJ omega squared is equal to 1 divided by 1 plus J stopband omega divided by J cutoff omega with the power of 2n is equal or lesser than stopband ripple deviation squared. After we rearrange this equation, the ratio of stopband omega with cutoff omega with the power of 2n is equal and larger than stopband ripple deviation with the power of negative 2 minus 1. This is the second equation. By considering the ratio between filter order and the discriminating factor, so we have passband omega divided by stopband omega with the power of 2n equal and larger 1 minus delta P with the power of negative 2 minus 1 divided by delta S with the power of negative 2 minus 1, which is equal to D squared, the discrimination factor. And after we rearrange this equation, okay, this is from equation 1 in the previous slide and this is from equation 2 in the previous slide. So after we rearrange this equation, we have n log 10 of passband omega divided by stopband omega, which is equal and larger than log 10d, the discrimination factor. The next one, we determine the filter order n, which is larger and equal to log 10d, the discrimination factor, divided by log 10k, the selectivity factor. The filter can also be defined in S domain. This is in the frequency domain, HAJ omega squared. So in S domain, it is equal to HAS multiplied with HA negative S, where S is equal to J omega and it is equal to GS. In S domain, GS is the transfer function, which is equal to 1 over 1 plus S divided by J omega C with the power of 2n. So we're taking the denominator to be equal to 0 for pole location. Okay, this is the denominator of the transfer function in S domain and this is the numerator. So to determine the pole, we determine from the denominator. Okay, and to determine the 0, we determine from the numerator of the transfer function in S domain. In this case, we take the denominator equalize to 0 to determine the pole location. In this case, the pole location is S equal to minus 1 with the power of 1 divided by 2n J omega C.